Welcome back to the Network Plus training series. In this lesson, we are covering Objective 1.7. Given a scenario, use appropriate IPv4 network addressing. This is a hands-on, scenario-based objective. You will not just be asked what subnetting is. You will be asked to perform subnetting calculations. Mastering IPv4 addressing is absolutely essential for the Network Plus exam. Let us start with the basics. An IPv4 address is a 32-bit number typically expressed in dotted decimal notation as 4 octets separated by periods. Each octet ranges from 0 to 255. For example, 192.168.1.100. In binary, each octet is 8 bits, and the full address is 32 bits. Every IPv4 address has two parts, the network portion and the host portion. The subnet mask determines where the division between these two parts falls. A subnet mask is also a 32-bit number. The ones in the mask identify the network portion and the zeros identify the host portion. For example, a subnet mask of 255.255.255.0 or /24 in CIDR notation means the first 24 bits are the network portion and the last 8 bits are the host portion. Let us review the original IPv4 address classes. Class A addresses range from 1.0.0.0 to 126.255.255.255 with a default subnet mask of 255.0.0.0 or /8. Class A provides a large number of host addresses per network. Class B addresses range from 128.0.0.0 to 191.255.255.255 with a default subnet mask of 255.255.0.0 or /16. Class C addresses range from 192.0.0 to 223.255.255.255 with a default mask of 255.255.255.0 or /24. Class D addresses from 224.0.0.0 to 239.255.255.255 are reserved for multicast. Class E addresses from 240.0 to 255.255.255.255 are reserved for experimental use. While classful addressing is largely historical, understanding it provides context for modern addressing concepts. Now let us discuss private versus public addresses. Private IP addresses are reserved for use within internal networks and are not routable on the public internet. The private address ranges are 10.0.0.0 to 10.255.255.255, which is a Class A range. 172.16.0.0 to 172.31.255.255, which is a Class B range, and 192.168.0.0 to 192.168.255.255, which is a Class C range. Any address outside these ranges, excluding special reserved addresses, is a public address that is routable on the internet. APIPA, or Automatic Private IP Addressing, uses the range 169.254.0.0 to 169.254.255.255. When a device is configured for DHCP but cannot reach a DHCP server, it assigns itself an APIPA address. If you see a device with a 169.254 address, it means DHCP has failed. The loopback address is 127.0.0.1, and the entire 127.0.0.0/8 range is reserved for loopback. This address always refers to the local device itself and is used for testing the TCP/IP stack. Now let us get into subnetting, which is the most important skill in this objective. Subnetting is the process of dividing a larger network into smaller, more manageable subnetworks. There are several reasons to subnet. It reduces broadcast domains, improves network performance, enhances security by segmenting traffic, and allows more efficient use of IP address space. CIDR, or classless interdomain routing. Notation uses a slash followed by the number of network bits. For example, /24 means 24 bits for the network and 8 bits for hosts. /25 means 25 bits for the network and 7 bits for hosts. Let us work through a subnetting example. Given the network 192.168.12 with a /24 mask, if we need to create subnets, we borrow bits from the host portion. If we borrow 1 bit, changing the mask to /25 or 255.255.255, we get 2 subnets with 126 usable hosts each. The 2 subnets would be 192.168.1/25 with a host range of 192.168.1.1 to 192.168.1.126 and a broadcast of 192.168.1.27 and 192.168.1.128/25 with a host range of 192.168.1.129 to 192.168.1.254 and a broadcast of 192.168.1.255. The formula for calculating subnets is 2 to the power of the number of borrowed bits. The formula for usable hosts per subnet is 2 to the power of the remaining host bits, minus 2. We subtract 2 because the first address in each subnet is the network address and the last is the broadcast address, neither of which can be assigned to a host. Let me share some common subnet masks you should memorize. /24 is 255.255.255.0 with 254 hosts. /25 is 255.255.255.128 with 126 hosts. /26 is 255.255.255.192 with 62 hosts. /27 is 255.255.255.224 with 30 hosts. /28 is 255.255.255.240 with 14 hosts. /29 is 255.255.255.248 with 6 hosts. /30 is 255.255.255.252 with 2 hosts, commonly used for point-to-point links. VLSM, or variable length subnet masking, allows you to use different subnet mask sizes within the same network. This is important for efficient address allocation. For example, a point-to-point WAN link only needs 2 addresses, so you would use a /30. A department with 50 users might use a /26. VLSM prevents wasting addresses by matching subnet sizes to actual needs. Network Address Translation, or NAT, translates private IP addresses to public IP addresses, allowing internal devices to communicate on the internet. Static NAT maps one private address to one public address. Dynamic NAT maps private addresses to a pool of public addresses. PAT, or Port Address Translation, also called NAT overload, maps multiple private addresses to a single public address using different port numbers. PAT is the most common form of NAT used in homes and businesses. Let us review the essential points. Know the IP version for address structure, classes, and private ranges. Master subnetting calculations including CIDR notation, subnet determination, and host calculations. Understand VLSM for efficient address allocation. Know the types of NAT. Practice subnetting problems daily until the calculations become automatic. Thank you for watching this lesson on Objective 1.7. In the next video, we will cover Objective 1.8 on modern network environments.